Yes, sir, I'm doing well.
I heard you got a pretty good score on the ACT.
Yes, sir, I got a 30.
Yeah. Do you know yet whether that gets you into the school? You're trying to get into the University of Auburn?
Yes, sir, that gives me 80% of, it basically pays for 80%.
Uh-huh. Okay. Cool. Okay. I think we left off the chain rule, right?
Yes, sir.
Okay. First of all, do you need a little review on the power rule, product rule, and quotient rule?
I think that might help.
Okay. Let's start with this right here. Hold on a second. Let me turn my screen on. Sketch pad. Yeah, let's start. Run.
All right, so that is 2x.
Y
This
prime.
one is cosine x. That's right, because it's the, that is 3, right?
All
Right.
Yeah, if you get it right, I won't say anything.
Okay.
I'm assuming that we don't need to review it if you get it right.
That is 1 plus cotan of x.
No, the derivative of tangent is secant squared.
Secant squared. Okay.
And it's definitely worth memorizing all 6 trig functions. Remember, the only 3 you have to remember are sine, tangent, and secant.
Yes, sir.
In other words, once you've committed those to memory, then you can always figure out the cosine, the cotangent, and the cosecant.
That's right.
Let's review just to make sure. I'm going to write the trig function. You give me its derivative.
Yes, sir. All right. That is the cosine of x. Secant squared.
And notice why I do it this way.
Isn't that the secant x tan x?
Uh-huh. That's all you have to remember.
Okay.
The others,
That's all.
yeah, because the others you can figure out. If you didn't memorize this, you can figure it out based on what the sign is.
Okay. That is the negative sine of x, right?
Yep. In other words, all of these cofunctions, the cosine, the cotangent, and the cosecant, are negative. So I know there's a negative sign there. I know there's a negative sign there. So
that's right.
What's that derivative?
That is the negative. Is that the negative cosecant squared?
Yeah, it's whatever the cofunction of that is.
Okay, that's right.
And finally, this one?
That is the negative cosecant cotangent.
That's the way you memorize them. Commit those 3 and commit the method you're going to use to figure out the other 3. But I don't know, might be easier to just memorize all 6. There is a lot of memorization in calculus for sure. It's worse than trig. All right. Let's talk about the chain rule.
Yes, sir.
Or let's not talk about it. Let's see how much of it you remember.
Okay, so the chain rule.
What's a better way to write that original function?
Wait. Oh, x squared plus 1 to the 1/2 power.
Oh, that's a better way because we're going to use the power rule. So
That's right.
radical signs do not help at all in calculus. Anytime you see a radical sign, whether it's square root, third root, fifth root, doesn't matter, convert it to a exponential or fractional exponent.
That's right.
Okay, so y prime is what? Now, this is a composite function, first of all. Okay, in other words, it's of this form. That's what a composite function is.
That's right.
Okay,
You have the outside and the inside.
F of x would be square root of x, and g of x would be x squared plus 1. So if you were looking at what f of g of x is, it's the square root of x squared plus 1.
That's right.
Okay, and when you are doing derivatives, you do the derivative of the outside first. That's what that means. And then you do the derivative of the inside, and you multiply. So if I'm taking the derivative of f of g of x, I'm going to do f prime of g of x times g prime of x. That's where the verbal comes from, where you take the derivative of the outside times the derivative of the inside.
Yes, sir.
Okay, so what's the derivative of this thing?
All right, so that's going to be, let me see if I remember how to do this correctly. So that is
the outside times the derivative of the inside. That's all I always want to be thinking.
1/2 times x squared plus 1 plus.
Oh, hold on. What do you have to do to the exponent?
Oh, that's right. Wait. It's the exponent minus.
Minus 1.
Okay, yeah, minus 1. So the negative 1/2.
Okay.
Plus.
Times, not plus.
Oh, times.
Remember, right. It's the derivative of the outside times the derivative of the inside.
Yes. All right. So that is 2x. Yeah, 2x.
And that's the answer. Now, if you're dealing with a multiple choice test, then this, you might not see that as a choice. Because usually when they have a problem and they start you with a radical sign, your answers are going to have a radical sign. So if I convert that to a radical sign, 2x is in my numerator. 2 times that is in my denominator.
Yes.
So that's the equivalent of what above it. And in fact, I can do that. So this is the answer you would see on the multiple choice. Of course, you could have done that to begin with also.
Yes, sir.
All right. Let's look at another one. The derivative of the outside.
That is the cosine of 6x.
It's the derivative of the inside.
6.
And normally, even though to me, I'm always going to remember it as derivative of the outside times the derivative of the inside, in most cases, you end up writing it the derivative of the inside times the derivative of the outside. Because you can kind of see why. This is the better way to write it. If I write it like this, that's confusing. I don't know if that's the whole argument of cosine or where the 6 is separate from the trig function.
That's right.
So you almost always want to put that number in front like that. And what ends up happening is that usually you write it as the derivative of the inside times the derivative of the outside. The problem with doing it that way is that frequently there are two insides. And so the rule becomes the derivative of the outside times the derivative of the first inside times the derivative of the second inside.
Yes, sir. Or
times the derivative of the third inside. And then you simplify it after you get it all done. How about this one here?
Five times 3x plus 2 to the fourth times 3.
Here's your answer.
Yes.
Okay.
Okay.
Remember, derivatives of the sum or difference of two things is the same as the derivative of the first thing plus the derivative of the second thing.
All right.
When they're being multiplied, not true. When they're being multiplied, you have to use the product rule. If this was x times tangent of x squared, yeah, we'll do that after we do this
one. All right. So we're going to have 1 plus the secant squared of x squared times 2x.
Very good. Okay. Now, make that a multiplication. Just as further review of the product rule and the chain rule.
Okay, so the product.
Okay, here, let me write up here in the right. If you have two functions together, product rule is the first function times the derivative of the second plus the reverse.
Okay.
That's what you want to remember. It's really easy to remember if you think about it. It's the derivative of one of them, or it's one of them times the derivative of the other one plus the reverse. That's what you have to remember. So yes, I recommend everybody start it out with that one. Whatever u is, start your writing there.
All right. So x.
Now, figure out what the derivative of tangent of x squared is.
Secant squared x squared plus.
Hold on. Got to apply that chain rule.
Oh. Wait, what? Yeah.
Now,
that's
right. Here's what we're doing. We're doing v prime. V is tangent of x squared. So you have to take the full derivative of tangent of x squared. And in that derivative, you have to apply the chain rule also.
That's right. So times 2x.
Correct. And I can multiply that to produce that. Okay?
Yes, sir.
Plus what?
Plus, it's just going to be 1. So tangent of x squared.
Right. And that's the answer. And I don't think I can do anything with that in terms of simplifying it. Okay. Now, most chain rules are pretty obvious. What is the inside and what is the outside? There is one in particular that people have trouble with, and for a reason. You can understand this one or the subtleties of this one, you'll have chain rule mastered. What's y prime in the first?
Okay.
And to answer both of these, you have to know what is the inside. Because that's what it comes down to, is knowing what the inside is. You can't take the derivative of the outside times the derivative of the inside unless you know what the inside is.
Do you want me to just use the chain rule for the top one, or?
You're going to use the chain rule for both of them. But both of them require you to know what the inside is. So yeah, go ahead and apply it to the top one.
Okay, so the first derivative of the sine squared of x is...
It's the inside on the top one.
The inside is x.
Actually, the inside is sine of x.
And
the reason is, here, let me write it up here. I'm going to let u equal the inside. So what we're looking at here is u squared. All right?
Oh.
And now, if I apply the chain rule to that, I'm going to do 2u times the derivative of u, which is 2 sine x times cosine x. You with me?
Yes, sir. I think so. And
well, I'll leave it up here. I'm not going to erase anything because now let's do the second one. What's the second inside?
so this is x squared.
Yeah, completely different. So if y equals the sine of u, what is y prime?
That means y prime is the cosine of u.
Times du dx. What is du dx?
That is...
Take the derivative of u.
2x.
Yeah. Now if I go back and substitute, this is actually x squared. So the derivative of the outside is cosine of x squared times the derivative of the inside, which is 2x.
Yes, sir.
Okay. And like I said, if you can understand the subtleties of these two problems, you're 90% there in terms of the chain rule. The differences between these two.
Yes, sir.
Because everything is what is in the inside. The first case, the inside is sine x. In the second case, the inside is x squared.
So the formula for multiplication Is U the inside or the outside?
The inside.
The inside. Okay.
Yeah, so this first one is actually u squared. Whereas the second one is the sine of u.
Hmm.
There are
So,
other ways to do this first one. I could make it be sine of x times sine of x and use the product rule. But that would not be the best way to do it, because this subtlety between these two questions is the biggest part of the difficulty of chain rule, is you have to know what the inside is.
okay, so
Most of the time it's a lot clearer than it is here.
okay.
We had one earlier that was tangent of x squared. What's the inside of that?
That's x squared.
Yeah, so it meant that the derivative of the outside is the secant squared of u times the derivative of the inside, 2x. So knowing what u is critical sometimes. Most of the times not. You don't have to get that deeply into it most of the times. It's going to be clear. This is probably the hardest case I can think of when I'm teaching people the chain rule, is that use this as a big example, because it didn't get much harder than that. In other words, if I give you something like this, cube root of x to the fourth minus 2x plus 1, well, that's easy what the inside and outside is of that, right?
Yes,
In other
sir.
words, if I convert it to this, to what power?
The 1/3.
Give me the derivative of that.
That is 1/3 times x to the fourth minus 2x plus 1 to the negative 2/3 power times 4x to the third
Yeah, always start with that exponent. Don't start anywhere but that exponent.
minus 2.
That's it. All right. Let me see if I can find some difficult chain rule situations here. Well, just going to go through the ones in the book. They're pretty interesting.
Yes, sir.
Now, I understand that I haven't shown you anything practical about calculus yet. You just got to get over that and get through all these memorizing things. And then we'll start talking about where it's applied in real life and
Yes, sir.
how it's useful.
All right.
But for the first few weeks of calculus, it's pretty much all rote memory stuff. It's difficult to apply it to anything other than the slope of the tangent line. And that is key. Always remember that that's what first derivative is the slope of the tangent line. Because
Yes,
the
sir.
next questions are going to be, what is the equation of that tangent line when x equals 3? And, okay, so we'll start getting into more real life problems there. But until then, it's pretty much all memory.
Yes, sir. That is so we're going to use the quotient property.
We could. That's actually the hard way to do it. In other words, an awful lot of time, you can change the quotient rule into the product rule by just rewriting it. In fact, that's the way I did it for the first 6 months I learned it, because the quotient rule was so hard to memorize. I didn't have a nice, convenient way of memorizing it, so I changed all quotient rule problems to product rule. So how would I write this to use the product rule instead of the quotient rule?
Would you just, that would be, oh, okay. Okay, I was thinking, okay, yeah, yes, that's right.
Okay, now apply the power rule to that along with the chain rule.
All right. So that is -1 times x plus 1 to the -2 times 1.
Correct. What that is -1 over x plus 1 squared. So whether the product rule or the quotient rule is easier here, I'm always going with the product rule, because that quotient rule is a devil to reduce.
It is.
You need all your algebra powers to reduce it, whereas the product rule comes out pretty much in its final form immediately.
Yes, sir.
Okay, I'm looking for tough ones, and they're getting hard to find. I'm going to have to go a little further here. Here's a good one. Rewrite it first.
All right. So that is x squared minus 1 squared all to the 1/3 power.
Simplify it.
Okay. So, oh, we're just simplifying this?
Yeah.
Okay.
In other words, there's two different ways to do this problem. One is I actually have a composite function that is the result of three functions. Notice that I have the cube root function, I've got x squared minus 1, and I have something squared. Those are the three functions. So I could apply the chain rule twice. And we'll get to that later, but I don't actually need to do it here if I simplify it first. If I simplify it first, then I only have to apply the chain rule once. So what's the simplification of that?
So that's going to be x squared minus 1 to the 2/3.
Now, take that derivative.
All right.
Apply
So
the chain rule once.
2/3 times x squared minus 1 to the -1/3 power times 2x.
That's it. Okay. Keep looking. Usually don't have to look very far to find tough problems in this book that I have. This is as good a book as there is as far as I'm concerned on calc. This is the AP Calc book, which means college level.
Okay. Do we want to rewrite this for the product rule?
That's the next line.
All right. So that's going to be -7 times 2t minus 3 to the -2. And so with the -7,
always start right there.
Always start right there.
Always. Take that and multiply whatever coefficient you have.
Oh, Oh, that's right. Okay. So it's going to be 14 times 2t minus 3 to the negative 3 times 2.
Good. Okay. Let's just talk about this for a second.
All right.
Is there an f of x that is undefined? Is there an x that makes f of x undefined?
This f of x?
Bad example, I guess. No, that's a good example. Yeah. In other words, this is, now in some cases, in other words, you could take the derivative of this easy enough, right?
Yes, sir.
But the mere fact that this function is this function means that there are constraints on what x can be. In other words, let's talk about the domain of x.
Wait, is that a negative 2/3?
No, it isn't. I wrote it wrong. Sorry. That actually matters. Hold on a second. Yeah, let me change it to illustrate a point here. Let's make it negative 2/3.
All right.
Now, what is the domain of that function right there? And remember, the way to think about domain is start thinking about what x can't be. Because usually, a lot of times, domain is all real numbers. And so thinking about it in a way where thinking about what the domain can't be, what x can't be, what do you come up with?
For this, it's, oh, okay. Now it means something. So the x cannot be 1.
Correct. So x,
Or negative 1.
no, negative 1 would be okay. Because negative 1 makes that denominator minus 2 squared, which is 4. And the cube root of 4 is not 0. So the only thing you got to be careful about with a lot of these domain questions is don't let the denominator be 0. So start your problem out with that cannot be equal to 0. So what does that mean? It means x can't be equal to 1.
That's right.
All right, these problems, let's kind of draw them at you.
Okay.
Rewrite it.
Y equals x squared times 1 minus x squared to the 1/2.
Now you can't further do anything with that. So what is y prime?
So would we have to use multiplication for this?
Well, this is definitely the product rule. Because yes, you have two different functions that are being multiplied.
Yes.
Okay.
All right. So we have x squared times 1/2 times 1 minus x squared to the negative 1/2 times negative 2x.
Perfect. And we won't worry about simple. Might be worth simplifying. We'll see what we get.
Wait, do we still have one more?
Oh, yes, my fault.
So it's just going to be plus 2x times 1 minus x squared to the 1/2.
Yeah.
Okay.
Not quite.
Oh.
On the no, that is perfect. Yeah. In other words, you did u times v. That whole thing is v prime plus u prime times v. And you have to think of it like that, so you don't make mistakes like I almost did. And I tell you, that this is an easy mistake to make, where you drop it after you do the first part of it. You forget the second part. At least it's an easy mistake for me to make, is forgetting the rest of what's being added to that. It's not the first time I've made that mistake. Okay, let me look some more. Okay.
All right. So we have.
What's the inside?
The inside is 3x squared.
Okay. So what's the derivative of the outside?
So the derivative of the outside, that is the negative sign of 3x squared times 6x.
Good. Okay.
So that is negative 6x sine 3x squared.
Right. Yeah. I mean, you don't have to rewrite it. As long as I use this parentheses like I did, then that is not the argument of the sine function.
Yes, sir.
But it's usually correct to rewrite it to avoid any difficulties. This is interesting. Let's do this one. Very similar. This is really the way to write it if I want to eliminate all ambiguities.
Okay.
In other words, if I want to make sure that 2x is not part of the argument, I got to write it like this.
All right. So this would mean that it's cosine of 3 times 2 plus the sine, negative sine of 3 times 2x.
Yeah. Hold on, let me just check to make sure we end up with the correct answer here. Ah, now I get why I didn't. Let's go back and do this. Sorry about this.
All
Let's do that one.
right. So it's just x squared.
Uh-huh.
All right. So cosine of 3 times 2x. So 2x cosine of 3 plus the negative sine of 3 times x squared.
Okay. Which gives, the heck, how do I not get this? Just a second. Must be some simplification I'm not seeing. Just a second. I'm either looking at a typo or I'm looking at my own brain fart. I don't get that answer. What the heck? What am I doing here? Now I know what I'm doing. Yeah, that's not the answer. First of all, let's talk about this. What is that?
That is
Is that a number or is that a variable?
is that is it that the sign of something can't be greater than 1?
No, this has more to do with knowing whether that's a number or is that a variable. Is it a number? Stick it into your calculator.
Oh.
Cosine of 3 is a number.
Okay.
Okay. And the derivative of a number is 0. So this whole part of it gets crossed out. And this becomes your answer. Because if the cosine of 3 is a number, then the derivative of it is not minus sine of 3. That's actually what was wrong. The derivative of it is 0. It's only if there's a variable in there that the derivative is minus sine.
Yes, sir.
And it's the same with, say, natural log of 2. If you want to take the derivative of natural log of 2 is a number. So the derivative of it is 0. It's not 1/2. Let's talk about that as long as I mention it. Y equal natural log of x means y prime equals 1 over x, right?
Yes, sir.
But if y equals natural log of 2, that's a number. That's not a variable anymore. So y prime equals 0, not 1 over 2.
Okay.
Okay? So wherever you can convert these, what are they called? Functions, transcendental functions, which are the trig functions and some other kinds of functions. But wherever they convert to a number, make sure you recognize it so you can make the derivative of that 0.
Yes, sir.
I'm glad we did that one. I might not have realized that. Okay, let me look more. Hold on. Talk about repeated applications of the chain rule.
All right.
Now, remember when I write y prime here, what I really mean is what is dy dx? Now, hold on a second. No, I don't. No, I can write it as just y prime with respect. In other words, I want to know what y prime, I want to know what dy dt is. That's what I want to know.
All right.
Dy dt. I want to take the derivative relative to t, not x, which is the same as writing y prime.
Okay.
Okay. Start with the derivative of the outside.
So that is the cosine cubed.
Always start with your exponent.
That is 3 times the sine squared of 4t.
Correct. Now what's the first inside?
The first inside is...
Not the last. I don't know that it matters, but in other words, you can either figure out the first one or the second one. Obviously, one of them is 4t, right?
That's right.
But let's go in order here. We just did the outside times the first inside. What's the first inside?
Sine of 4t.
Okay. What's the derivative of that?
Cosine 4t.
Now take the derivative of the second inside.
4.
That's how you do it when you're applying the chain rule twice. And there are some functions where you could apply the chain rule 6 times or
Wow.
12 times, whatever. There's no limit as to how many times you apply it. But it always comes down, and I think that's the reason they teach it, the derivative of the outside times the derivative of the inside. Isn't for when there's only an outside and an inside, but it's for when there's an outside and multiple insides.
Mm.
And the way you have to kind of think about it is start with the outside and then just start working your way down through all of the insides.
Yes, sir.
Okay. And obviously we take that 4 and multiply the 3, so that becomes a 12. And that's the answer. 12 sine squared of 4t times cosine of 4t. All right. Now, good place to talk about near the end. We'll get to our first they want the equation of the tangent line of this graph at the point pi comma 1. That is the quintessential question in differential calculus, is give me the equation of the tangent line. Okay.
All right.
When you're talking about equations of straight lines, what's the most important thing?
The slope?
Yeah, absolutely. If you have a straight line, the slope is by far the very first thing you want to consider. Well, what's slope equal to? Well, let me ask it a different way. What's first derivative equal to?
So that is... Oh.
So here, I can make this a little clearer, maybe. This is that function graphed. Okay.
Oh.
And this is pi. So I want the slope of that line. I want the equation of the slope. Well, whenever you're talking about the equation of a straight line, you're always, first of all, find the slope.
Yes, sir.
So what's f prime?
All right. So that's going to be 2 cosine x, right?
Uh-huh. Plus what?
Plus, all right, so this is going to be the negative sine of 2x times, okay, so negative 2 minus 2 sine x.
Sine 2x. In other words, don't change that when you're doing the derivative of the outside.
That's right.
The first thing you did was you're going to take the derivative of the outside, and the derivative of cosine of 2x is negative sine of 2x.
Yes, sir.
Okay, so now the next step, let me erase that graph. Have a little room to write. Is they want what is the slope when x is pi?
Okay.
So what is f prime of pi? In other words, f prime evaluated when x is pi. I don't really care what y is. Everything's a function of x. The only thing I need to know is x is pi.
That's right. So we just plug in pi for x?
Yep. Into the derivative equation.
All right. So that's going to be
cosine of pi minus 2 sine of 2 pi. Well,
that's right.
Let's come up with that number. What's 2 cosine of pi equal to?
Is that negative 2?
Yep. And what's sine of 2 pi equal to?
That is 0.
So our answer is minus 2. That is the slope of the tangent line when x equals pi. Okay. Now, there are 2 standard equations of straight lines. One is y equals mx plus b. That's the one you almost never use in calculus. The one you always use in calculus is point slope.
Okay.
Which is this one right here. It's called point slope because you have a slope and you have a point.
That's right.
Well, we have a slope and we have a point. So let's put it into slope point format. What's y sub 1?
Y sub 1 is, that's 1, right?
Correct. What's the slope?
Negative 2.
What's the rest of it?
X minus pi.
And that is the final answer. I do not have to simplify that. That is in point slope format. And that's always the format you deal with in calculus, because what you usually have is one point and the slope being derived from the first derivative. So this is always what your answers are going to look like. And you don't simplify it. I mean, if it's a multiple choice, you may be looking at, y equals something. But in general, you do not have to go beyond that. That's a better answer than actually y equals something. Just because that's the way of calculus, is to put it into point slope format. So let's do another one of those. These are useful and they are so needed. I guess I'm going to have to make some up here. Maybe not. Yeah, here I got some. So let's do this. So the instructions on this are come up with the equation of the tangent line at that point.
All right.
Rewrite it.
So that's 3x squared minus 2 to the 1/2 power. So that's 1/2 times 3x squared minus 2 to the negative 1/2 times 6x.
Now what's the next thing I need to write?
Are we going to simplify that?
No, not yet. Don't need to, because this is a middle step of the answer. They're not asking us for f prime of x. They're asking us for the equation of the tangent line. For our own self, we need to figure out what f prime of x is, but we don't need to simplify. What do we need to do? We need to evaluate it at what number?
3.
Correct. Now notice that why waste time simplifying?
That's right.
Okay. Now, what is the slope at this point? 3, 5.
Is it,
It's in the numerator. Whereas the numerator is made up of those two things.
so it's 9.
Okay, what's in the denominator?
That is 7, the square root of 7. Yeah, the square root of 7.
Square root of 7. Now, it's also not super important. I guess it may be. Let's go ahead and rationalize that. To be honest with you, I don't know what they do.
9 root 7 over 7.
Okay. Now, what's the equation of the line? Here, let me make just a little bit of room here. We figured out the slope. We have a number for the slope. What format are we going to use to put it into the equation of a line?
What slope?
Okay. Substitute everything.
Y minus 5 equals 9 root 7 over 7 times x minus 3.
Yeah, that's the answer. That is the equation of that tangent line.
Yes, sir.
And like I said, if you were to take a test and they could only ask you one question, that's what it would be. Give me the equation of the tangent line of this function at this point.
Yes, sir.
So this is definitely something you want to remember how to do. All right. That's a good place to stop, too. I'll have to look a little bit in advance. Okay, looks like the next thing in the book is implicit differentiation. It's a good topic. All right. Garrison, I'll talk to you next week.
Yes, sir. See you then.
Thank you. Bye-bye.
Have a good week.
You too.